Good morning, lovely tenors. Right, buddies, next lesson that we're doing online together, we are going to be continuing on with the amazing sampling unit, which you guys have really excelled with so far. Your first one looked really good when you did random sampling, using the random number generator on the calculator, and then figuring out which values you should pick based on the random number. And you were good at the systematic sampling as well, which is where you started somewhere random, but then you counted on like every 10th one, so you got all the way through the data. So you're good at both of those. So here's the very best type of sampling of them all, and it's called stratified sampling. So you should put the title Stratified Sampling. Now, here is what a stratified sample is. Rather than just picking randomly or picking in certain increments of what we've done so far, what we actually do is we're going to try to get a sample which is actually perfectly reflective of the population that we're sampling. So yeah, I'll give you a chance to write that down. What you're going to do is you divide population into groups, and then you take a sample from each. Group, so that the number that is asked per group is proportional to the whole population. So I know that's a mouthful, and I know that it sounds like it's complicated, but it won't be. I promise. It's going to be nice and easy for you. So yeah, I would say that you probably do actually need to jot this little part down just here. Make sure it's in your book, because on the tests and stuff, they do sometimes actually ask you to write a definition, unfortunately, so you do have to know what that is. So if I was you, I'd pause the video right now and just do a little jot of that. You divide the population into a group and take a sample from each group so that it is proportional to the size of the group. Cool, pause, write it. Okay, buddy, and you're back. So here we go then, lovelies. I'm going to show you where you'd actually use this in real life, and this is the best type of sampling. Here we go. The example I've made up is this. It says, Mr. Duffy wants to figure out what students think of the canteen and the studio food at AGS. But he doesn't want to ask all 1,375 kids at AGS, because that would be ridiculous. That would take way too long. And it would be, I don't know, say that you had to take a day off work. It'd be costly because the school would have to replace him with somebody else. So he's not about to do that because it's expensive and it's not an efficient way to go about things. So what he's going to do is he's going to just do a sample of kids instead. Okay? So they're going to say, I'll ask a few kids, but I'm going to take their opinions as reflecting everyone's opinion. Now, here's the thing. He wants to do it completely fairly. So he's going to carry out what's called a stratified sample, and he's only going to ask 50 students. But the thing is, if he knows there's 155 kids in year 7, year 8, year 9, year 10, 11, and then there's 325 in year 12, but 275 in year 13, here's what he can do. He's going to give the year 12s, when he gets all these opinions back from people, he's going to listen to what the year 12s think a bit more than he's going to think about what the year 10s think. And the reason for that is, year 12s are actually a bigger customer for him than what year 10s are. Does that make sense? So you should count their opinion for more, because there's more of them. Similarly, he's going to care about what the year 13s think more than he cares about what the year 10s think, but he's not going to care what the year 13s think as much as he's going to care about what the year 12s think. And so what he's going to do is he's going to try to work out an optimum number of people from each year group to ask, because if he can get his 50 kids he's going to ask to match proportionally with the number of kids in the school, it means that every single person has got a fair their opinion has been counted fairly. Cool. Now I'm going to show you I want to tell you something cool as well. Oh, no, I'll show you first, and I'll tell you something cool after. So here's what we're going to do then, buddies. We want to know how many year 7 kids that we're going to ask. Now, it's not too complicated, actually. Here's what you do to figure it out. If you want to know how many year 7 kids to ask, you need to know what portion of the kids are year 7. So before I even show you what to do, I bet you can already do this pretty much by yourself. If there's 1,375 kids at AGS and 155 year 7s, well, what portion of the class or what portion of our school is made out of year 7s then? Well, exactly. You should have got 155 out of 1,375. Does that make sense? I hope it does, because that is just kind of that's the portion that are. It's 15, yeah, that is literally the fraction of kids that are in year 7. But the thing is, that's the portion, and how many kids do we want to ask? Well, we're going to ask 50. And if we're going to ask 50, all you're going to do is you're just going to times by the 50. Cool? So say your 7s were half, you'd do half of 50 and 25. You'd ask 25. You'd ask 25 of them because that's the same as half. Cool beans? So that's the calculation there. What's the calculation for year 8s? Well, same deal again. 155 out of 1375, and you go times 50 because that's how many we're asking. 155 out of 1375 times 50, and so on. Yeah, and that's what you're going to do to get it all worked out. So I'll show you what you're going to do now. You pop it into your calculator. So let's do it. 155 over 1375 space, then push the times button. 50 equals, oh no, we've got a strange old number. It's 15.6. So that's a bit funky. It's 5.6. So here's the thing. I'll have to show you this at the end. 5.6. I'm going to round that to 6, okay? Because we can't ask a portion of a person, and 5.6 rounds to 6. So we'll call that 6, call that 6, call this 6. These are both 155s as well, so that's 6, and that's 6 too. What's the calculation for the 12s? Well, let's check them. 325 over 1375 times by 50. What's it going to be? Let's go back on the calculator. Delete. And we'll go 325 equals, I got 11.8, so 12. And 275, let's do it as well. 275 out of 1375 equals, let's do it. 275. Okay, there we go, and it's 10, and that one's not rounded. Okay, so that's perfect. Here's what we have just done then, buddies. If we're going to do a random sample, we're going to take 6 of each of the year groups, but 12 year 12s and 10 year 13s. Now, everyone just have a little brief look at that, and then tell me if that's okay, what I've done there. Will that work if we're going to ask 50 kids? Okay, well, let's look. 6, 12, 18, 24, 30, 42, 52! Oh dear! So there's 52 altogether in this, okay? So we've asked too many. So here's where it gets a bit funky, and here's where it gets a bit less like maths and more, so a bit, I'll write this down in case you're trying to follow along. That equals 52, which is too many. Now, here's where it gets a little bit more statisticsy and a little bit mathsy. What are we going to do to correct that? Well, here's what you're going to do. We're just going to have to lop 2 kids off, and it stops kind of being accurate. So you think to yourself, where would be a good place to lop kids off of so everyone is still fair? Well, for sure the year 12s, they already have 12 say in it. So what we can do is we can cross them down and ask 11 of them instead. Now we're at 51, so basically it was a rounded number. And then you have to think to yourself, we can either take one off of one of these year groups or we can take one off the 13s. What would you do? I'd take one off the 13s. That's what I'd do as well, because that kind of maintains the proportion. It shows that the 7s to 11s are all are equally represented, and the ones that had extra votes, we just cut a couple off of them, and now it's done. So if you're going to do a sample, what you do then is you get your whole list of 155 year 7 names, and then you do a random sample of 6. And you get your year 8 names. Then you'd use the random number generator, and you'd go a random sample of 6. And you go with the year 13s, you do a random sample of 9 using all the year 13 names. So it matches just perfectly up with the last topic that we just did, but we know now that we're just going to ask this many of each year group because that matches the whole population. So I hope that that makes sense. Does that make sense? Good. Okay. I'm going to tell you a fun thing just because I like it. It's political, but I like it. I always like the politics stuff. I don't know if you ever watched an election result happen in the UK or even in the States. We've watched the American election just, didn't we? When Donald Trump didn't get elected, thank goodness, but he didn't get elected again, and we watched that happen on the telly, right? Did you notice that different spots, let's go back to the UK actually, but did you notice that in different parts of the UK, it seems like some regions of the UK get way, way, way more votes than other regions of the UK. So if you look at a map, or even with the coronavirus that's happening, when you look at the maps that the BBC makes or that you see on the telly, you always find that London, even though it's just one spot in the whole country, London's always broken down into millions of little sections. There's well, maybe there's not millions, but there's dozens of little sections of London, whereas our entire area of Warwickshire, that's like it's a great big area. It's got like Leamington in it, it's got Ulster in it, it's got Stratford in it, it's got Warwick in it, obviously. It's got all these places in it. But whereas little places in London, each one has got its, like even though it's just a small area, it's got tons of sections. And when you look at things like elections, it seems like places like London get way more votes than us. Now, here's the funny part that's controversial. We might only get we might only get a few votes in Warwickshire, but then in London they get like dozens. And does that seem fair? Do you think it is fair? I'll give you a hint. It is fair. Do you know why London would get more of a say? It's because it has way more people. So those people need to be reflected. So actually, voting is a stratified it's a stratified kind of example. When you do votes, they do break the country down into populations, and you get more votes depending on your population. That's why London gets so much say, and that's why when you look at a map of the UK at the end, like the area that has Inverness, like in the north of Scotland up there, that whole section that like curls around over the top only like gets one vote between them, and that's because that number of people in that whole like huge portion of the country is only equal to like one London district. So like it might just be equal to just Westminster, for instance, that whole part of Scotland. So actually it is fair because it represents the number of people. So there's my little interesting point. Cool. So here's what I'm going to get you to do. You saw how this calculation just worked, right? This stratified example calculation. You did see how that worked. So here's what I'm going to get you to do. I want you to do the exact same thing here on these three questions, okay? So don't pause the video just yet, but I'll tell you how to do it. So I'm just going to read this one to you, but then I want you to do it by yourself and the other two, because this will be part of the thing that you'll take a picture of and upload for me. And yeah, so we're going to ask 150 people. Here's a table showing the number of students at Geometry High. So you got to work out how many kids there is altogether at this high school, okay? So add all these numbers together. That gives the total 1. And then, I don't know, say it doesn't equal 1,000, but let's just say it equaled 800 people. What you're going to do is the first one will be 100 out of 800. And then what you're going to do then is times that by 150. That would be how you'd do it, okay? Same deal on 2, same deal on 3. Take a picture and upload it for me. Cool, that's task 1. So you can pause now and have a look and have a try. And task 2, my lovelies, is this. We are going to go back to our amazing tree sampling activity. And the final thing I want you to do, the final thing I'm going to get you to do with these trees is this. Remember, we're doing a stratified... Ooh, can I not write on this? Where's the pens? I can't write on it. Disaster. Okay, I'll have to just speak to you, so you'll have to pay close attention. Remember how we're going to only ask 20 trees? Are we only going to take a sample of 20 trees? Well, here's the thing. We know for sure, off the bat, that there are this many of each sort, okay? So there's this many of each one. 55 beech, 65 birch, 40 elm, 36 oak, and 5 yew trees. Okay, I want you to stratify that, okay? Which means I want to know what fraction, so we have to know how many trees there are in total, which I don't think it tells us actually. Oh yeah, it does, 200. There's 200 trees in total, okay? So what you're going to do is figure out how many of each tree that you want to do. So this will be 54 out of 200 times by 20, 65 out of 200 times by 20, and so on, and that'll tell you how many of each one to do. And let's just say, for instance, I'll actually do the calculation for you. So 54 divided by 200 equals that, times 20 is, oops, oh, I didn't do that right. 54 divided by 200 is 0.26 times 20 is 5. It should be 5.2. Am I being weird here? I think it's 5. The 5.4, I mean, it should be. It's 5.4, I'm sure it is. Yeah, it's 5.4. Yeah, it's like the same as timesing by 10, yeah, anyway, or divided by 10. So it's 5.4, so you choose 5.4 beech trees. I'd round it down to like 5, like we did in our last example, and see where we go from there. So I'd choose 5 beech trees, and then here's what you do. Go to your list again. Can you see that the beech trees are all the first ones, okay? So we're all the way down here to like number 197. Here's all beech trees. Here's what you're going to do. Random number generator it. So just count this as tree 1, and this is tree 2, and tree 3, and tree 4. So ignore their actual numbers, just count them down the list, and say that you random number generated between 1 and 54, and you got 3. Well, this will be the tree you count then. Then random generate again, and maybe you got like 7. 1, 2, 3, 4, 5, 6, 7. This will be the next tree that you write down. And then say you did it again, and you got tree number 52. Well, you'd be like, it's that one. And you'd count that. Get me? Cool. So all your activity is for today is to do those 3 questions and then to do me a average height of the trees using a stratified sample. So choose 5 beech trees, choose, I don't know, for instance, 3 birch trees, 1 elm tree, 2 yew trees, whatever. See what I mean? Get the average for each of the categories, get your trees from each of the categories, and then add them all up and divide by 20. Done. And that's all I want you to do. So I hope that's okay. You did really, really good last time, buddies. And yeah, keep up the fab work and see you again soon. Bye, buddies!